215 million years ago, in a floodplain that would one day become the red deserts of New Mexico, a small, sharp-eyed predator moved through the undergrowth on two long, bird-like legs. It weighed barely as much as a large dog. It stood roughly a meter tall at the hip, and yet this animal, slender, fast, and almost fragile-looking, belonged to a lineage that would eventually dominate the planet for the next 150 million years. This is the story of Coelophysis, one of the earliest dinosaurs we know in real anatomical detail, and one of the most complete fossil records of any Triassic animal on Earth. Every claim in this documentary is drawn directly from real specimens, real excavation records, and real peer-reviewed paleontology. To understand Coelophysis, we have to understand its world. The Late Triassic was not yet the age of giant dinosaurs. The supercontinent Pangaea was still largely intact, its interior a hot, seasonally arid landscape of braided rivers and semi-desert. Dinosaurs were new arrivals, a minor branch of reptiles sharing the world with far larger and stranger animals. Armored atosaurs, crocodile-line predators called rauisuchians, and early relatives of crocodilians that in some cases outweighed and outnumbered the dinosaurs around them. In this world, Coelophysis was not a top predator. It was a quick, opportunistic hunter, built for speed, not brute force, and that build is exactly what its skeleton reveals.
Coelophysis was named in 1889 by the American paleontologist Edward Drinker Cope, based on fragmentary remains from late Triassic rocks in New Mexico. The name means hollow form, referring to the hollow, lightweight limb bones Cope observed, a feature we now know is shared across nearly all theropod dinosaurs and their living descendants, birds. For decades, Coelophysis was known from scraps. That changed in 1947. In the summer of 1947, a team from the American Museum of Natural History, led by paleontologist Edwin H. Colbert, was excavating at Ghost Ranch in Rio Arriba County, New Mexico. What they found was staggering. A massive sandstone block packed with dozens of Coelophysis skeletons tangled together in death, preserved in what appeared to be a single catastrophic mass mortality event. This locality, now known as the Whitaker Quarry, became one of the richest single dinosaur bone beds ever discovered. Some blocks removed from the site, quarried whole, plaster-jacketed, and shipped to museums around the world, contained the interlocking remains of multiple individuals in a single slab, from hatchlings to fully grown adults. These quarry blocks are astonishing pieces of evidence. In this specimen, the tail curls in a tight arc back toward the skull, a posture called the death pose, caused by the drying and contraction of neck ligaments after death, known scientifically as opisthotonus. It is one of the most recognizable postures in dinosaur paleontology, and Coelophysis is one of the animals that helped define it. Slabs like this one preserve more than one animal at once, evidence that Coelophysis likely lived and died in groups. Whether that means true social behavior or simply many individuals converging on a shrinking waterhole during a Triassic drought is still debated among paleontologists. But the sheer density of skeletons at Ghost Ranch is unmatched at almost any other dinosaur site in the world. Casts of these original blocks, like the ones shown here, now travel to museums worldwide, letting the public see firsthand
exactly how these animals were found, interlaced, curled, and fossilized together in the same layer of ancient river sediment. A fully mounted Coelophysis skeleton reveals a body built entirely for speed and agility. The neck forms a graceful S-curve, a hallmark of theropod dinosaurs that persists structurally in birds today. The vertebrae are lightly built, with deep hollow chambers that reduced skeletal weight without sacrificing strength. On-screen caption: cursorial hind limb proportions. The hind limbs are disproportionately long compared to the torso. The lower leg, or tibia, is actually longer than the fibre, or femur. In living animals, that ratio is a strong indicator of a fast runner, seen today in animals like ostriches. Coelophysis likely relied on speed and darting agility rather than raw power to catch prey and avoid larger Triassic predators. The forelimbs, by contrast, were short and ended in narrow, clawed hands, most likely used for grasping small prey rather than for locomotion. Everything about this skeleton points to a small, active, opportunistic predator, fast on its feet and quick to react. The skull of Coelophysis is long, narrow, and lightly built, with large openings called fenestrae that further reduced its weight. The jaws carried small, curved, blade-like teeth with fine serrations along their edges, a tooth type paleontologists call zyphodont. This dentition is well suited to slicing flesh and gripping small, fast-moving prey, insects, small reptiles, and juvenile animals of other species that shared its environment. Multiple skulls recovered from Ghost Ranch and other Triassic sites in the American Southwest allowed paleontologists to reconstruct the animal's head with confidence rarely available for such an early dinosaur. Modern replicas and study casts, like these, are still used today by researchers and museums to examine cranial anatomy without risking the original, irreplaceable fossil material. For decades, Coelophysis carried a dramatic reputation, the cannibal dinosaur. In 1947, Edwin Colbert examined a specimen, catalogued as AMNH-FR7224, and reported what he believed were the bones of a juvenile Coelophysis preserved inside the body cavity of a larger adult. The idea that this small dinosaur ate its own young became one of the most repeated facts in popular dinosaur books for over 50 years. But science self-corrects. In 2006, paleontologists Sterling Nesbitt, Alex Downs, and colleagues re-examined that same specimen using more advanced imaging and preparation techniques. Their conclusion, published in the years that followed, overturned the original interpretation. The bones inside the body cavity were not a baby Coelophysis at all. They belonged to a small crocodile-line archosaur, a different animal entirely, likely scavenged or preyed upon, not cannibalized offspring. This story matters because it shows paleontology in action, a widely repeated fact tested against new evidence and revised. Modern exhibits, like this one, which reframes the original find as a predator-prey interaction rather than cannibalism, reflect that corrected science. The type species, Coelophysis boweri, is the animal most of the Ghost Ranch material represents. For a time, some of the Ghost Ranch specimens were reclassified under a separate name, Rheoaribasaurus colberti, after a dispute over whether Cope's original 1889 specimens were adequate to anchor the name Coelophysis. In 1996, the the International Commission on Zoological Nomenclature formally resolved the dispute, designating a ghost ranch skeleton, AMNH-FR7224, the very specimen at the center of the cannibalism debate, as the official name-bearing specimen, or neotype, for Coelophysis boweri. This restored Coelophysis as the valid official name. A second species, Coelophysis rhodesiensis, originally described from Zimbabwe, is now generally classified in its own closely related genus, but for years was studied alongside C. boweri as a close cousin from the opposite end of Pangaea, evidence that this general body plan was successful across a huge span of the ancient supercontinent.
Coelophysis holds a distinction no other dinosaur can claim. In 1998, a fragment of a ghost ranch skull was carried aboard the Space Shuttle Endeavour on mission STS-89, making it the first dinosaur fossil to travel into space. It's a fitting footnote for an animal that has done more than almost any other Triassic species to teach us what the very first dinosaurs actually looked like, how they lived, how they died, and how science corrects itself when new evidence comes to light. From a single fragmentary description in 1889 to a mass grave uncovered in the New Mexico desert, to a re-examined skeleton that rewrote its own reputation, Coelophysis remains one of paleontology's most complete, most studied, and most revealing windows into the dawn of the dinosaurs.